Hello, YouTubers. This is a new session where we get to talk about event-driven architecture. And then I'm going to introduce you to a nice open source library that I just released called EventHighway, which is like a simple .NET based configurable, pluggable library that anybody can contribute to, but more importantly, anybody can understand and know how it works and, all the little, details of it. So without any further ado, let's just start talking about event-driven architecture as a theory. What is event-driven architecture? Why it's important? Why should you care? Can't you just, hit the same thing over and over every day, make it time-based, and until something changes, and then you do something with it? Let's find out. So, in event-driven architecture, imagine that you have a service, some service. It doesn't matter what this service is. And this service is interested in knowing that when a student in some system, let's say you have a system, you have a microservice or an API running, so let's just call it students API. So this is an API, it has a database attached to it, and maybe has a UI attached to it, and you're very interested, this is a storage like this, and let's just say there's a UI, just a portal or something where teachers go in and they basically say, you know what, we want we want these students. So this is here, school portal, right? So this is a portal where teachers go in and they want to, kind of update student information. And let's just say, every time a student is, marked as absent, right? They never went to school, right, that day, and they were marked in the system as absent, right? An email and a text message and maybe a notification of some kind needs to be sent to the parents of the student to let them know that they haven't attended school that day. So there are two ways to solve that problem. You have the teacher coming in, or whoever, the admin or whoever, and they're basically entering details here through that portal. So they're basically going and saying, well, Ali is, this is the admin, and Ali didn't come to school today. So they send an event. So basically think of it as a put. So put, let's say they're putting and calling an API and they're saying students, and they're basically saying, hey, we're sending a call, to this database, and the database now has a record that says this student has been absent from school today. How do you send emails and text messages, and how do you notify, a bunch of other services that, a particular student didn't go to school? You have two ways of doing this. One way would be, oh, I need to go and hard code, like literally integrate, something with the text messaging service and the email service and maybe the app notification service. So this student's microservice here knows about all of these, right? So every time a student is absent, it has to call all of these, and maybe one of them will fail or one of them is not available, and the data is lost, right? Because let's say they called the text messaging service. Let's just call it text messaging service in here, or microservice, and the text messaging service is down, right? What's going to happen? Two horrible things could happen. This, if it's the first service that the school students API is calling, then it's not going to continue because it terminated the whole process. Very bad programming. You should never do that. You should fire and forget. Just fire events. But even worse, if it continues even to the other services, let's say this is the email microservice like this, and this is the, I don't know, phone notifications you want to send to an app microservice, and each one of them is concerned with a particular way. What's going to happen is that it's going to go and say, oh, well, I did my part. These two went through, but this one failed. And then you're going to have to go and build a retry logic and, do a lot of things that are just really, really complex and shouldn't be part of a simple student API that's mainly focused on, updating student information and reflecting that through a portal. Okay, so one way to do it is to inform the provider, which is the student's microservice, about the consumers, the potential consumers. That's one idea. Another idea is to go the other way around, which you'll see a lot of people do, right? A lot of people will go and say, okay, we don't have to do that, but what we can do is to have these services ping the student's microservice, or every student in the system. I'm going to go hit that student microservice here every day, every hour of every day, or once a day, whatever the case may be. So this is the time-based, it goes and hits and be like, hey, do you have any students that have been reported absent today? And go do that every day, every day, every day. And it's really chatting and it's really time and resources consuming because you're going to get all that traffic that's actually for nothing because all this traffic that's going on is basically an API call that may or may not be fulfilled because there's no guarantee that there's an actual data change that happened there. So instead of actually having students microservice send to these services will try to hit every day. Have you ever been in a system where someone is doing a time-based and they keep checking every day like that? Check, 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 check like that until, some data change. That's also bad, right? It's bad for so many reasons. Even though it does fulfill the idea that the provider doesn't necessarily know much about the consumers, that's fair. But the problem here is that the provider now becomes extremely busy, right? Think about this annoying person that keeps coming and knocking your door every hour and saying, hey, are you done with work yet? Are you done with work yet? Very annoying, right? It's the same thing with architecture, right? You don't want that naggy person that keeps coming and hitting your API over and over again, until what they're looking for is complete. Now imagine if this person comes and does that every day, whether there is change in data or not, they keep doing that over and over. So not the best way to do architecture, for software. So what's the alternative? The alternative is to do something called the subscriber publisher model, or publisher subscriber model, which is event-based architecture. What this means is that when something changes, you're going to publish to a particular topic or an address or whatever it may be. So that provider is basically saying, hey, something changed in my database, and I'm just going to announce that to this, events component. It could be event hub, it could be topic, it could be anything you want. It doesn't matter, but just focus on this component, because what this component is doing is saying, I have subscribers, like these guys subscribed to that particular topic. Let's say the topic is student record change, right? So there's this topic, and the student record has changed. And every time the student record changes, the provider will notify, doesn't know anything about these consumers or subscribers. And these subscribers will be notified without this provider having to know anything about who's listening on the other side. Okay, that's event-based architecture. You're triggering an event, and whoever is listening on the other side is going to take advantage and know what to do, right? There are so many products out there. Like, let's just say this is publish and then notify, so the call will go right back here, and then you'll basically say, okay, go ahead and notify. So subscribe and notify. So they first subscribed, subscribed, and then basically will get notified. Each one of them will do that, the exact same thing. Each one of these guys will do the exact same thing, just like that. Okay? Well, if that's the case, well, that's fantastic, because that basically means that you get the ability to make your system only trigger API calls if and only if someone is subscribed or interested in that, right? Now, there are so many products out there. There are so many things out there. The most popular of these is, you probably have heard of Kafka or RabbitMQ, or your regular Event Hub, or there's so many different implementations of this, right? The problem with these implementations, and I'm going to walk you through it right now. I'll tell you what is the problem with the current implementations in the tech world today. First and foremost, complex implementations, meaning that, actually let me break it down to you even better. So let's say, pub sub components, let's say whatever these components are, they break into two pieces, right? Some of them are open source and some are not open source, right? Some are open source, so OSS, and some are proprietary. I hope I said that right. Proprietary, like that. Okay. Proprietary meaning that you can't run it local. If you want to try to run a simulator locally, you can't, because you don't own it, you don't own the component, you don't have it, right? You can't run that normally on your local machine. Okay. But even for the OSS ones, they face another challenge, which meaning that it's complex. Way too complex, right? Proprietary, meaning no airplane mode. No airplane mode, meaning that you can't run it locally if you want to do an internet, if you're in an airplane, literally, or you're in a place where there's slow internet or no internet, you want to run this in a pipeline, right? And you want to build locally, you have to be connected to some components that's in the cloud or in another server, whatever the case may be. It doesn't work out. So this violates this principle, being able to run in an airplane mode. Big problem. And even the OSS ones like Kafka and RabbitMQ and whatnot, way too complex. Like I looked at the repositories for these products, and it's very hard to get an idea about what's going on. Even though the idea of PubSub is really, really simple. Like the idea is you have a bunch of subscribers, and when an event happens, you call every one of these subscribers. You may implement some retry logic and whatnot, but I don't know, things got really complex. And this happens a lot, especially in the open source world. Something starts really simple, and then requirements come through, a lot of requirements, and then maintaining the simplicity of this without standardization becomes an extreme challenge, right? Because you're trying to maintain a system at level 0, right? You have to have a standard. But what if there is no standard? Then everybody's just going to throw whatever they want to implement that deliverable, whatever that deliverable is. And then as time goes by, the system gets more and more and more complex to the point of becoming completely unmaintainable. And then comes in another savior to say, we need a full rewrite of our system, right? And that full rewrite will take a long time, and then people will get tired halfway or they'll leave the project. So many things that happen, right? So it's really important to stay at a level where anybody can contribute to this project, anybody can understand it, but more importantly, it stays at level 0. That's a standard principle, level 0. Keep it simple. So with that in mind, this example here in mind, you saw the 3 different examples, and that's the best example that you could have. We can implement, a simple library called EventHighway. And what this EventHighway does in simple terms is that you can be a provider of some kind, and you're gonna basically send an event to EventHighway component, and then all the subscribers will be notified from that EventHighway, right? I'm gonna put them here on this side so you just understand the flow, because there's input, output, and then there's dependencies. This EventHighway implements something called iStorage Broker, right? And the final version of this will allow you to plug in any kind of storage you like. It's very configurable. You can pass in iStorage Broker, something that will concretely implement iStorage Broker, whether you're using NoSQL or files or memory or whatever you want to use, it doesn't matter, right? But this beta release looks at a SQL server, but you also still have to pass in a connection string because you own that data. And the data is so simple, even an 8-year-old can understand it. It's very simple. It's a bunch of tables, and these tables kind of work in that particular way. And I'll explain that to you in a second. So this is the subscriber. And what basically happens is that you're sending an event, send the event. The event will go through the EventHighway. We'll go find out all the listeners, and boom, send it back to the subscribers, right? So number one, really what's happening is that you register event address. That's the topic or the thing that people want to subscribe to. And then you want to register subscribers. Someone who's interested in that event address. You registered, I call them a listeners, basically. It's listener, event listener, like that. Right? And then what happens is publish event like that, just like that. And then once that event publishes, what's going to happen is that it's going to call listeners, event listeners. And then finally, record listener event, meaning that for every call that happened in that system, it's going to record, that this event has been received or something has happened to it or whatever the case may be. Right? 1, 2, 3, 4, 5 steps. Couldn't get any simpler than that. That's exactly like the extent of simplicity is to basically go and say, here's a place where people are going to be interested when an event happens. Register people that are interested in that event. Publish an event to that particular address. So that event is going right there, right? It goes right into that address. You're basically saying, here's a new student, or here's a student that's been updated, whatever the case may be. And then what this is going to do is it's going to call the listeners, right? These are the people that just listened to that event. You know what? Let me put it on the other side so it's pretty, like that, right? And then what happens? Once that's done, let me make it like this. So this guy is going to call this guy, and this guy is, kind of adhering to this guy, and then record event listen. The last thing is to basically go and say, hey, something happened, right? And this thing that just happened, I'm going to update whether it failed, succeeded. Here's the response. And we're going to talk a little bit more about fire and observe versus file and fire and forget. This is file and observe because of recording that listener event. I'll come back to you later about why that's important and why that kind of puts EventHighway ahead of any event-based architecture or product out there. Okay, talk is cheap. Show me the code. What does that look like in the real world? I started a new Visual Studio project here for you. So we can basically go ahead and create a new one. A simple console app is fine. And this is EventHighway.demo.app. So it's just a quick demo for you. Here we go. Okay, let's take away the silly things. So let's disable all that stuff. We don't care about that. Disable. And let's pull in the library. The library that we care about is called EventHighway. It's out there, the beta release. Really, go ahead and try it. I promise you it's going to change a lot about the way you think about things, right? So let me type EventHighway. Looks like a lot of people already thought about the idea of EventHighway. So here we go. Okay, I installed the library, right? This guy is freaking out because I kind of said I want to. By the way, just for the people who are interested, why I disable, like a lot of people say, Hassan, come on, why are you disabling implicit usings and nullable? I disable this one because if I want to take a snippet and share this with someone and tell them, hey, go use this, there's no way they'll know what dependencies I'm calling. Some smart pants will come and say, oh, well, Hassan, just put it in Visual Studio and it will figure it out. Well, there are ambiguity between models. And if I don't know exactly if it is Hassan at models, Hassan core models versus, I don't know, using, Nadim.core.models, how do I know if both of them has student in it? There is no way to tell. So unless your snippet and the piece of code that you're showing, I like code that tells me the whole story without any ambiguity, right? It doesn't do anyone any favor either way. If you're trying to reduce the file size, it's your architecture and code development problem, not that the system is telling you what you're using and whatnot. That's of course in addition to the fact that every other programming language will tell you what this is, maybe except for JavaScript or something like that uses global usings, which just abominations everywhere. Okay, let's get back to the topic. So I want to create, I want to use this EventHighway. So I'm just going to go and say EventHighway client. Okay, here's new EventHighway client. Great. This client basically wants something from me. What does it want as an input parameter? It wants you to pass in the connection string, right? So connection string. It needs to pass that in there. So string, connection string. So this is the first good thing about this project is that it basically gives you the ability to control where your data is being stored, right? Some other, event-based systems, it's a mystery. You don't know where the data is being stored. How do I go and debug? I like systems that are super transparent and clean, that you can look at it and know exactly where the data is being stored, what's the problem, and all that kind of fun stuff. In addition to using just, common technologies like Entity Framework, C#.NET, and stuff like that, you know what this is. It's popular enough for you to know to go and debug and maybe change it if you want to. Now I want a sample connection string. Let's use AI for this one. So I'm going to do control. What's the secret? Is it alt slash? Aha. Generate a local connection string for local DB or something like that. I'll never remember that, but maybe this guy can. Come on, baby, you can do it. There you go. There you go. That's perfect. So it basically went ahead and created this local connection. It basically hits your local database, right? We just need to kind of, there you go, even gave it a nice name, EventHighway Demo DB. I love it. So this is my connection right here, right? It's going to create a new database for me. And this database is going to create in the local database server, hence it's running local. And it's just going to go ahead and, basically start adding stuff to it and do all that fun stuff. Okay, great. So that's connection string. So first of all, we're creating the connection, and then I basically created the client. What else? So get that EventHighway client, and I wanna register. I wanna go to event addresses, right? And I'm gonna go and say register event address. Now, what is that? This event address here, my friend, is how we basically gonna create what is equivalent to a topic, like a something of interest that people want to listen to. It's like when you're going into the radio station, right? I don't know if a lot of people today listen to radio, but back in the ye old days, people used to kind of tune in into radio stations, and you're basically going to a particular kind of signal or a particular radio station, I don't know, 97.5 or whatever the case may be, whatever the number may be. So, okay, so I want to register an event address. So I'm going to go here and say event address. Here's my event address. Please take away that stuff like this. Oops, let's pull in the. So what is an event address? Go ahead and create your own kind of GUID. Go and create a name, demo event address, fine by me. Demo event address, create a date, created date and updated date, right? I'll tell you later why these are important. And then what else? Is there anything else that needs to be done here? If I do control space, it'll just show you the attach events. Okay, great, because it's entity framework based. We can hide those as well, but I don't want to. So this creates an address. Fantastic. I want to know what this address is, so I'm going to go and say event address, target event address, like that. Here we go. Target event addresses, like that. And this is my, I don't know why I put equal there. So that's your target event address. So created the topic, the address where all these events are going to go, and where it's basically the single point of contact between listeners and providers, right? And the language they're both speaking is basically the event itself, which we're going to talk about in a second. Okay, cool. Now let's register some listeners, right? So let's go ahead and say, well, event listener, like that. Here's a listener, event listener equals, and here's a new event listener. And what I want to do with this listener is that I basically want to go and say, have this listener register, to that particular address. So I know what the address is. Let's save the address in here. I'll use it from the object itself because it's better this way. Why this guy's tripping? Because event listener. Oh, be careful because event listener. Remember when I was telling you about the usings? Event listener apparently is also a model on the tracing library for Microsoft.NET. Just pay attention to that part. Okay, this guy will also have an ID. It's great. I'm gonna create a event address ID, which is that target address that I just told you about. I'm gonna say this is listener number 0. Number 0. I don't think it has a name actually. Maybe I should add a name to it at some point. That would be nice. But the endpoint, it has an endpoint that we need to update at some point. Created date, updated date, sure, updated date, and that's it. So that's a listener. So I'll call that listener number 0. And I'm going to create another listener for you just so you know about the fanning out capability that we just talked about. So you understand that these listeners are listening to the same thing. So how do we do this with these listeners? Well, the easiest thing to do is just create a couple of projects and spin up these projects and see if you're actually hitting the endpoint on these projects. So I'm going to go ahead and create a couple of projects here. Just a quick API, just a couple of quick APIs. Create new project. And let's call this a core APIs, ASP.NET Core. It's just a really simple API. And this is event, let's say highway event demo. Listener API 0, like that. Let's create this one. All I want from this guy is to really just give me an endpoint that basically says, I am here and here's my controller. Let's create a quick controller here. So API controller empty, events controller. See, I'm even calling it events controller. You don't have to call it that. Call it whatever you like, but this is specifically for that. Your your listener has to have a post endpoint. You can't have a get or patch or put or whatever the case. It has to be particularly, a post endpoint. So let's put an action result in here. I action result. I'll show you why that's important in a second. Was it action result? Let's see. Public action result post. Yeah, something like that. And this event will come through. Let's create an example of that event. That event could be anything you want locally, right? It can be anything. Let's say call it name or whatever. And then I'm just gonna send back that event. I'm not doing much with it. I just want to put a breakpoint in here and run this guy, so you know that this is API 0, right? So if I run this guy, it'll kind of generate, I mean, you can get that from the properties as well, but what you really want, you want this particular, and you want to make sure the endpoint is working. So if you do try and hit execute, it should hit that breakpoint, so you know that this API is actually working. But what we really care about is the endpoint itself. The endpoint itself, which is /events. So API /events right here. I'm going to go back to my program, which is the EventHighway program, and say this is my endpoint, API/events. So that's my first listener. Okay, so that's my first listener, right? Let's put another listener just for the purpose of this particular demo. I'm going to go and create another one. Create a new project, call this project ASP.NET Core API, the same thing that I just did basically. What did I call it? EventHighway, highway demo. I don't even remember. What did I call it? EventHighway demo listener API 0. Okay, so it's just one here, dot listener API 1. Another one. So these are a couple of listeners, a couple of APIs. And these APIs running locally on my machine, and I am just having them listen to my events. So here's the API, give me an empty. So let's call this one, things API, things controller. Why I'm making it different name? I want you to know that you're not really tied up to the name. Oh, that was bad. I want you to know that you're not really tied up to the names. Like you have your own local controller. You name whatever the object that's coming your way, whatever you want. So things controller. Same thing. Same thing that I just did. HTTP post like that, and then action result thing, create a thing, generate type thing. It went ahead and created a type thing. I want this type thing to have the same thing though, the same properties, and I'm gonna take it away from here and put it here just for the purpose of this demo, so you know that I really mean this. We're really talking about the exact same thing. So thing coming through, send thing to response, and have this thing running so we can get the information and verify that your API is actually running the way you expect it to. So here's execute, and I'll give you the information that you just posted. What is the thing on that? It's 723. Cool. Cool. So that goes right here, /API/things. Okay. So according to this story that we just did, we are sending to a particular event. We have registered events and listeners, right? Assuming everything goes well, we need to actually create those listeners, right? So I'm going to go here and say, well, await EventHighway registered listener number 1. Here's 1. And also register the second listener, because you have to register these listeners, right? So here we go. And register the second listener as well, which is listener number 1. Okay, we have 2 listeners. We registered an event address, and we registered listeners towards that particular address. The last thing we have to do is to basically publish an event against that address. So let's create an event. @event. The @ here is just to escape that because it's a reserved word and whatever. So let's publish a simple event coming from EventHighway. The event has to know where it's going and what it's targeting, but it needs to have also its own ID. So here's the content of that event. So remember how we needed to create some object. Let's create an object in here. So public class some object, some event, and that some event will have a prop, string name, right, and string description. So let's create one of these. Let's go ahead in here and basically say JSON convert serialize object new some event with some details in it. What are these details? You know, it has a name, EventHighway event demo, and a description basically in here that basically simplifies the demo of EventHighway, whatever. So that's the event that we're sending. And then put some more information here about your event, maybe, you know, the event address that I care about, what is the target, and created date, updated date. Is there anything else? I don't think so. There you go. Created date, updated date. So going again, we created a client, we created an address, super simple. Create a bunch of listeners, register these listeners, and then send an event. So how do we send the event? Await EventHighway client event, and then it's called, I think I called it submit event. Yeah, submit event success. Maybe I'll change that name later in a final version, say publish event. So it's a little bit closer to the idea of pub sub, you know. So instead of saying register event listener, subscribe event listener or something like that. So if this goes well, we should see a database in here gets created. But more importantly than the database itself, we should see really fun stuff in terms of, you know, having our API endpoints being called. Remember, we created, you know, 2 APIs. Here's a breakpoint on this one, and here's a breakpoint on the other one, which is this listener right here, events controller right here. So both of them has a breakpoint on it. To visualize what I just did, right? We basically created a really simple console app. Console app. And this console app is basically it's using EventHighway to store some data. So it's using this EventHighway to store some data in some database right here. Right? So that's your EventHighway. So the database is owned by this app, but the EventHighway is helping kind of, you know, processing. And when an event happens, we're going to pretend that event comes through. It's basically going to publish to these subscribers. It's going to go and say, you know, hey, listener 0, listener 0, and listener 1, go ahead and be notified about that event that's coming through. The beautiful thing about this is that this console app doesn't really have to know anything about these listeners, right? This is just for the purpose of the demo. We registered them in here. But whoever is sitting on the other side of these listeners, it doesn't matter at all, right? So let's do it. Here's the moment of truth. Let's go here and do the demo. We're gonna know real quick whether I need to redo that demo and cancel that video and start over or not. Let's run this and see what happens. Here we go. Boom, event 1 came through. Do you see how it subscribed and it sent the event 1, right? What about the other one? Event 1 too is coming through. If you go through with all of this, the process is completed. Right? Now, how do I know, like in this EventHighway, how do I trace that? How do I trace everything that just happened? If you look at the databases in here, you're going to find a fun database called EventHighway Demo right here. And if you look at the tables for this EventHighway, you're going to find the listeners that you and I just registered. Here's the listeners, and here's their endpoints. Super quick and simple and easy. The addresses, we registered only one address. You can see it here in the database. This is the demo address that we just created. And for every, and the event that we published, here's the event that we published right here. So here's the body of that event. We serialized it. We just sent it over the wire. And then last but not least, the events, like each one of them, what status code did they respond with. So you know exactly against that particular event address for that listener with an event ID of that model, you have the response. Here's the response that came, you know, from each one of these APIs. So if one of them fails, for instance, and I'm going to shut down one of them and run again, you're going to notice that it's fail safe. It says, okay, you're failing. It doesn't matter. That's not going to stop us from continuing to send to the other systems that are running towards that matter. So now that now that I showed you this whole thing, let's just publish a simple event instead of doing all that. I'll just publish a simple event. Like I no longer need the registration. I no longer need, create listeners or anything like that. I just need the ID for that address, which I don't have because it was truly randomly generated. Let's get rid of all of this, right? Let's go and take away all of that except for the event itself. So all of this goes away because that registration piece is done. You already have your listeners and all that, and you're just going to need to add that nice GUID in here. So GUID.parse, and here's your event. And so I'm connected to a database. Here's my event I'm publishing. That's it. And intentionally, I'm going to shut down one of these endpoints that I have running. So the one that was for the listener API 0, I'm going to shut it down. Let's just say this API is down. Does this impact my system? Let's find out. Let's run like this. There we go. It hit the second endpoint. Fantastic. And it terminated, right? So what happened? What happened is that if you go back to your listener events, you're going to see two more. Refresh this. You're going to see two more events. The difference is one of them failed. No connection could be made because the target machine refused it. And here's the details. See how beautiful this is? So even from a debuggability standpoint, you are able to basically go and say, well, I'm publishing to all of these events. I want to put a listener on the listener. I want to basically go and say, if an event could not be published for whatever reason, we need to know who that listener is, what event they couldn't listen to, and retry. So it's lossless architecture. Like you're sending an event, unlike the time-based, unlike the direct call. With a direct call, if it's kind of passive, meaning like if you fail, I'll just continue, then that data is lost forever. And you need to now go back and find out. This is a debugging nightmare for engineers at the enterprise level. If you have 120 or 300 microservices, and believe me, I saw it, it's going to be very hard to track down what actually happened instead of just getting an alert, a publishing event has failed. Go ahead and debug that. You have the exact same model, you have the exact same object that was being sent to that particular service, and go ahead and do that however you want. Now, some people might say, Hassan, why did you build this library as a core .NET library? Like, why didn't you build it as an API so people can just deploy it in the cloud? Well, I want it to be configurable. I want you to be able to go and say, it doesn't matter really what is the system that's a pub sub model. Right? You can write from a console app, you can run it on a Windows service, you can run it as an API. Take that core library and deploy it into whatever container you like, right? So I'm not limiting your ability, to kind of deploy this into whatever you want. And the next release of this library will also abstract away the idea that the listener is always going to be an API endpoint. It's just going to be an abstract event that gets triggered, and you just have to pass in these, how do you want to handle that particular event, upon publishing, which is going to make it even more sustainable and more configurable. It's going to support hundreds, maybe thousands of other scenarios that software engineers may need. Where can you find that stuff, right? This is really cool stuff. You should try it today. But if you really want to find where this is, all you got to do, just type in EventHighway. I don't know if it got to the top. Oh yeah, of course it got to the top. Fantastic. Just type EventHighway, maybe Hassan or something like that. I think it's just the event that, yeah, here we go. And that's your Nuget. Of course, I'm going to drop the link for you in the description of this video. If you click on the source repository, it'll take you right away to the documentation and all the changes that I'm doing. And feel free to jump in and kind of subscribe. This is still a beta release, meaning like we need a lot of work, and I really appreciate a lot of people kind of, Sunny, doing some work there to kind of get, some work happening for event handling and all that. Just amazing, amazing work. Also very, very, very special shout out to Gregory Hayes, a very prominent member of our standard community that always, keeps an eye on these things and makes sure that our standard, is adhered to. and our guidelines are actually adopted and respected. So there's that. And then I'm also going to push this example that I just made. I mean, if you go here, if you go into the app itself, you're going to find that example right here. This is the whole thing that I just did with you, right? Except that I hard coded the ID so it errors out so you don't register the same thing twice. But that's exactly the same thing. If you look at an event here, I even hard coded the serialization so I don't confuse you. I hope you find this a little bit interesting. It's a fun library. I promise you it's coming from the belly of a real life need. And I want, the standard community, but also, .NET community and even the bigger community of software engineers to reimagine, how event-driven architecture works. You can take that library today and hand it over to a chat GPT or an API, and they'll turn it to you into, or an AI, it will turn it for you into Java or Python or whatever library you like. I'm pretty sure there's something out there that does that. I just happen to be still one of the people that likes to kind of build my own things by hand. I'll use AI when I can, but in this particular case, it's much enjoyable to do it this way. I might also release at some point in time an existing wrapper, like an API, RESTful API wrapper, so people could just pull it out and deploy it in their system. Maybe we can build a UI component that helps you kind of, instead of going and digging into the database, you can kind of navigate from a nice portal, what events came through, were the listeners, and why did it fail? Should I click retry? Should I configure the retry ability? It's all going to be standard compiled. It's all going to be simple. And I hope you find this useful, maybe a little bit inspiring for you to kind of go build cooler things. And if you have any questions, comments, concerns, please don't forget to, feel free to drop a comment in the comment section. And as usual, don't forget to like, subscribe, and donate for whatever cause we have going on these days. Thank you so much. Take care. Talk to you soon.